This is the Building Automation Monthly Podcast with Phil Zito, episode 120. Hey folks, Phil Zito here, and welcome to episode 120 of the Building Automation Monthly Podcast. And in this episode, we're continuing on from episode 119, where we discussed the physical layer of networking, and now we're moving into the data link layer of networking. And if that is a little bit confusing, don't worry. I feel like I'm saying that a lot lately in these networking podcasts, but I realize that for a lot of folks in the BAS industry, you haven't been taught IT networking, and that's not your fault. The industry is just sucked at teaching us IT, but don't worry, we're here to take care of you. So in this episode, we're going to be going through kind of how local subnets communicate, how devices communicate. We're going to talk about MAC addressing. We're going to talk about address resolution protocol, basically all of the stuff that happens on a local subnet. Now, this is going to be pretty important because we are seeing more and more IP devices on local subnets. It used to be you'd have maybe a couple supervisory devices, but now we are going way beyond that. All right, so here's the deal. In the last episode, we got a lot of great feedback, a lot of folks saying that, man, you provided a lot of really good information for us. We're really taking it in, but can you give us some more examples? So as we move through this episode, we're going to cover what we need to cover, but we're also going to do so with even more examples. That way we can really drive this home. So what are data links? Well, when two devices, two hosts, or a host and a server, actually everything's a host coming off of a switch. Gotta use that terminology right? So two hosts communicating to one another on the same subnet, they have data links, and data links control the flow, they control error checking, they control a lot of stuff just to make sure that the data gets across the network reliably. Because if we don't get the right network, if we get network data across the network, man, that's a mouthful. If we don't get the right data across the network, things can get corrupted. We can have issues. That's why we've got things like redundancy checks. That's why we've got things like flow control. That's why we've got things that control how we signal across the wires. All of this we talked briefly about in the previous episodes, signaling, data, bits, and things like that. But at the data link, we're taking it a step higher because at the physical layer, it was all physical. There was no kind of logical things. A bit was a physical digital change on the wire. It was a digital voltage signal on the wire. Wires were physical wires. The ports were physical ports. But here we're starting to branch out of not just physical, but actually logical things. And this is where it starts to get a little harder for folks because we're talking about things that you can't really touch. You can see them. Granted, I've got on my left monitor here, I've got a Wireshark capture of a read property from BACnet IP, and I can see the logical things going on in the network capture. However, that's not something you can touch. However, also, it is something we can learn. So, with that being said, let's go through kind of our first example. And I like to use this example quite a bit when teaching what a local subnet is. So, if you think of zip codes, this is going to make a lot of sense to you if you're in the United States and a couple other countries. Those of you who don't have zip codes in your country, well, just follow along. So zip codes essentially break up a geography, and they're a geographic area, and within that zip code you have houses, you have street addresses, etc. So a subnet is like a zip code, meaning that within the zip code everything's within a pretty close range, everything can communicate, but if you have to get out of that zip code, then you go back to the mail office and you get routed to a new zip code. Well, that's the same thing kind of with subnets, right? If you want to get out of one subnet, you go to a router and you get routed to another subnet. We'll cover routing and IP traffic in the next episode, but within a local subnet, we are primarily concerned with what's called inter-subnet communication. And that is done through switches and local devices, meaning that these devices are physically connected to a switch. Now, this switch has what's called a default gateway, and that is where all network traffic that is not meant for this subnet is sent to. Once again, we'll cover that in the next episode. But all the traffic that is meant for this network is handled by the switch. Now, a little background here. Switches came about, the whole theory of switching came about with circuit switching. So circuit switching was back in the day, the phone operators, right? They would have these plugs in the wall, and when they would connect calls, they would actually switch circuits. So they would say, oh, you need to connect with such and such circuit. Well, we'll pull it out and switch you. They were called switchboard operators. Well, then we came out with basically the same concept, but in a software form. So what happens is that within the software of a switch, it can identify which port a host is connected to. And let's say you're host 1 and you want to connect to host 2. Well, the switch, as long as it's done its processes, which we'll cover in a little bit, is able to know which host is on which port. And so say, oh, host 1, you want to connect to host 2? Well, then I'm going to route you out this port. And so that is how networking at the subnet level works. It works through switching, but it's not circuit switching, it's actually packet switching. So you're switching around packets. And at this level, these messages go directly from the host to the switch to the next host, because it's all inter-subnet communication. It's all on that switch. Now, there is, you can have multiple switches and things like that. You can have switch stacks and things like that, but we're not going to go and dive through that. Now, at this layer, we start to introduce addressing. We start to introduce our first addresses for our hosts. Depending on what we're doing, specifically with BACnet IP, we're going to have several addresses. We're going to have a physical address, an Ethernet MAC address. We'll talk about that in a second. We're going to have an IP address. We're also most likely going to have a device ID address. And we're also going to have a BACnet address, which is a combination of the MAC address and the BACnet network address. So a lot of addresses. Fortunately for us, the MAC address is fairly simple. It is hard-coded into what is called a network interface card. And if you were to look at a BACnet IP controller, you would see where your Ethernet cable plugs into it. Once again, we're talking about wired Ethernet. We're not talking about wireless. We're not talking about 802.11 or Zigbee. We're talking about wired 802.3 Ethernet. Okay, so with wired Ethernet, we plug into our network interface card. And our network interface card has a MAC address, and that is, what is that, media address? Oh, I can pause this and Google that. Yeah, it's media access control. Don't you love the power of Google and just being able to search everything up? You don't have to memorize anything for mine anymore. Remember when I first took my exams for my IT master's degrees, when I took my exams for my IT certifications, having to memorize all that stuff, it was brutal. But fortunately, we can Google, and you can Google on your phone and look like a hero in meetings because you can have the answer real fast. Anyways, that's a little segue here. Learn your Google foo, it'll make you really awesome. That being said, so MAC addressing is used for addressing at layer 2, okay? It's really important that we understand that it's at layer 2. Now, Ethernet is the protocol we are going to be using. Now, you may be like, what? So Ethernet is technically called Ethernet cables, but Ethernet is really, it's a protocol. It is a form of packaging messages and transmitting them across the wire at the local subnet layer. Some other sample or examples of layer 2 protocols that you're probably familiar with, BACnet MSTP, that is also a layer 2 data link protocol. It is just using RS-485 and its master slave token passing instead of Ethernet. Now, here is the important thing. With all that kind of theory behind us now, right? How does all this communicate? Well, what happens is when you are communicating one BAS device to another, you have a switch, and that switch says, I want to reach host 1. How does it know it wants to reach host 1? It knows based on the IP address of host 1. Now, I know we haven't gone into IP addresses. We haven't even covered the next episode yet where we've gone into IP addresses, but just bear with me on this. So it does this thing called the IP address. Some of you know what that is. Some of you don't. By next episode, you all will know what an IP address is. But it has an IP address and it says, okay, this is my source IP, and I need to reach this destination IP. Now, these IP addresses are on the same subnet. So the switch knows it does not need to go to the default gateway to get to another subnet. At this point, it looks at its address resolution protocol table, or ARP table. And if there is an entry on this ARP table that matches this IP address to a specific MAC address, then it just simply looks at, okay, what port is that MAC address assigned to? Boom. If there's not, it sends out a ARP broadcast. And that ARP broadcast is essentially, it's all hexadecimal Fs, and it sends it out. And basically that is a equivalent to a 255.255 broadcast that comes out for IP. Well, this is the Ethernet version of a broadcast message. And a broadcast message is a message that goes out to all the hosts on the subnet. Now, broadcast cannot travel from subnet to subnet, so we don't have to worry about it leaving our subnet and discovering other devices. That's why if you send out a BACnet broadcast, if you send out, and it's a local broadcast, not a global broadcast, but a local broadcast, the devices you will find will be on that physical subnet. Same with Ethernet and data link layer, right? You send out your broadcast and that goes and it grabs all of the MAC addresses that are on that local subnet. And then it goes, it being the switch, goes and adds those MAC addresses to this ARP table, right? And this ARP table then stores, usually it's for about 5 minutes, and then it flushes them. Meaning it erases them and it sends out another broadcast, or if there's just any traffic going through, it just updates the timer on that. And so that's also why it takes a little bit longer to find stuff the first time you connect it. But with that being said, so the MAC address is in the ARP table, the switch knows which port to route it to. And that, my friends, is data link layer 2. And here's the important things we need to know, right? So the first important thing we need to know is that when we're communicating with our Ethernet communication, and I'm going to look at this Wireshark capture here, right? We need to understand source and destination MAC addresses. And why do we need to understand this? And we also need to understand that our devices have MAC addresses, because if we get some device ID, and I've seen this time and time again, where we have a device ID that's duplicated and we look at our MAC addresses in Wireshark and we're able to see the MAC addresses are different. And because I've seen folks go and enter the same IP and the same device ID on a BACnet IP device, and it was causing all sorts of havoc. And we went through and we looked at the MAC address, and the MAC addresses were different, and that's how you detect that there's device duplication. So it's understanding these concepts. This isn't just brute force memory, and it's not just Phil wants to be a geek and talk about, ooh, data links and da-da-da-da-da. No, what we're not going through, and this is why I strongly advocate against going through like a CCNA boot camp or something like that, because it's going to teach you so much of what you don't need to know. For example, we're not going through flow control. We're not going through whether this is full duplex or half duplex. You notice I haven't even explained what that even means. We're not going through what kind of protocol necessarily we're using for data link communication. This is stuff you don't need to know. The reality is, as much as folks talk about IT and networking and learning all this stuff, no IT person is going to let you go and log into their managed switch and start working on it. That's just not going to happen. Now, there may be a future where BAS folks become kind of outsourced IT and they become master service providers and you're managing the IT as well. I'll tell you from a lot of the OT networking software I've seen, like the Optigo network software that they provide OT networks, operational technology networks. A lot of that is software, graphical user interface managed, and a lot of it is kind of set and forget, so you don't have to dive into this level of depth. That being said, it is important to understand how the ARP table works. It is important to understand how MAC addressing works, because those two things could potentially interrupt your communication between your BACnet devices, which, let's be honest with one another, BACnet is the dominant protocol, at least at the time of this recording. Who knows what could happen? But it is our primary protocol, and it has two stacks, as we covered in our BACnet series. It has the OSI model stack, where it has MAC addresses, IP addresses, UDP segments, etc., and it has the BACnet stack with its BVLLs, its NPDUs, and APDUs. Okay, man, I feel like I went down geek rabbit hole there for a second, so we pull us back. This is going to be a shorter episode, and the IP episode is going to be a longer episode. But what we need to understand, once again, is that we have local subnets. These local subnets consist of a switch and an IP address range that is constrained to one kind of segment. It could be that you have multiple switches. Typically, it's a single switch. Typically, it's like a single 24 or 48 port switch. And on that switch, you have your access links going to your host. Your hosts communicate to the switch. The switch has that address resolution protocol table, which allows it to know the MAC addresses of the hosts. That way, those messages can get sent to the right hosts. And if a message is meant for a host that's outside of your local subnet, those messages then get routed via the layer 3 protocols, the IP protocols, which we'll cover in the next episode. The important point for us as BAS professionals is that we want to focus on Ethernet MAC addresses. We want to know our MAC addresses so we can detect device duplication, so we can understand which devices are communicating. And we also want to be aware of our Ethernet MAC addresses, because that's part of what comprises a BACnet IP address. With that being, BACnet IP device address. With that being said, that is episode 120. That is the data link layer. Sure, you all have questions. If you would like us to dive a little bit deeper into any particular topic, feel free to post your questions in the comment section at buildingautomationmonthly.com/120. Once again, that is buildingautomationmonthly.com/120. That's where everything can be found. And really encourage you, if you're struggling with IT, if this stuff's still a little Greek to you, even after the BAM TV episode and after the podcast, really encourage you to check out our IT course. It's much more structured. It is dedicated to teaching you everything you need to know, and it's step by step, and it's fully online without you ever having to travel anywhere. So go and check that out at buildingautomationmonthly.com/120. Thanks a ton for being here. Next week's episode will be much longer than this episode. Realize that this episode was a shorter one, and next week's episode will be a longer one because we are going to be discussing IP addressing, routing, broadcast, multicast, unicasts, static routes versus dynamic routes, and all the things in between. Thanks a ton for being here, and we'll talk to you next week. Take care.